So today guys, we are going to be building this neural network given right here, but we are going to be using the small part of this segment from the starting part. It's going to have convolutional part, then ReLU, then max pooling, then fully connected layer and ReLU. So we are going to be making this model for a 10 cross 10 image. Image dims are going to be 10x10. So 10 cross 10 pixels. So for that we are going to be using nn.sequential again because it's easier to implement. And here we are going to do self.network is equal to nn.sequential, and inside of that we are going to do nn.convolutional 2D con2D, and inside of this we are going to be writing the input channels, the output channels, and the kernel size. After that we need to apply the ReLU process, so we are going to do nn.ReLU, do that. And if you are thinking why it's not being colored, that's because I forgot a comma right here.
The greatest vtuber that's ever lived.
Okay, now after that we need to do nn.convolutional 2D, and then we are going to do it from 8 to 16 comma 3, and then we are going to do nn.ReLU again. So that's our starting part of the network complete. We have made this part right here, the first block, this whole part, convolutional plus ReLU, and then convolutional plus ReLU. Now we are going to add a max pool for it. So we need to do self dot max pool should equal to nn dot max pool 2-dimensional. That's going to be our max pool. So what this is going to do is it is essentially going to convert 10 to 5. That's the basic simple idea from what I have been able to diagnose. After that, we need to implement a fully connected layer. So we are going to do self dot fc is equal to nn dot sequential, and inside of this we are going to do nn dot linear. Oh, also guys, we are going to be adding padding. So padding should equal to 1 pixel, and here we are going to add padding is equal to 1 pixel. So what this is going to do is essentially save the image from collapsing, because if we do not add padding, then a large amount of data will be lost. So we are going to be adding padding for that. Now here we can do nn.sequential, and I think this should be 400 comma 8. No, let's do 400 comma 50. Yep. Okay, then nn dot ReLU and apply comma nn dot. Okay, before we do that, I need to apply comma because VS Code is such a pain in sometimes. Oh my goodness. I need to go down, not like this. I don't want a hint. Damn it.
The greatest vtuber that's ever lived.
50 comma 1. Now what we are going to be doing is defining a forward method. So def forward self comma x. So x is equal to self dot net x, and after that we need to do x should equal to self dot max pool x, and then we are going to be flattening it. So right now our output from this part is essentially in a matrix dimension, so we are going to be flattening it into a linear dimension. So we need to do x is equal to torch dot flatten, and we are going to be flattening x comma 1. So 1 is for the dimension, so 1 stands for the x-axis. I think 2 is for y-axis. So this is the piece of code that I have written. We are basically defining a model, and then we are generating a random input on 10 cross 10 image size right here, and then we are passing the tensor into the model and printing it also. So let me add one last line of code, return x. So now if we run this code, we should see some output at least.
A few moments later.
And there's the output. So that's how you can make a simple CNN model using PyTorch. Do make sure to subscribe. In the next video, we are going to be using this trainer that we made in a previous video to train this simple CNN model. So yep, that's it for this video, and I will see you guys in the next one.